own HASP member, Gary Morris, needs little introduction and really has little. However, he does have a BA in economics from Michigan State University, an MS in artificial intelligence, and a PhD in machine learning from the University of Pennsylvania. Many of us know him for his engagement as well as erudition. So without further ado, here's Gary.
Well, that was certainly the most enthusiastic introduction I've received in HASP thus far. Thank you, Bruce.
Sure.
Our topic this morning is going to be what happens beneath the browser. And I'll give you just a quick outline of what we're going to be talking about. We're going to be talking about two different scenarios with your browser. First is how your browser handles a web page request. And then we'll talk about how the browser handles a search term. As part of that, I'm going to give a little bit of history about the development of search engines, and we'll talk a little bit about Google's methods because they are the dominant search firm. I'll throw in as a little no extra cost feature, a list of searching tips that you might find useful for making your searches more powerful. We're going to spend the last portion of our time talking about implicit bias on the web. That's a theme that HASP is pursuing this semester, and certainly there's a strong connection to the internet. So we're going to talk about self-induced bias. We'll talk about confirmation bias, digital style. We'll talk about invisible racist bias, and then I'll give a few examples. So my favorite subtitle for this lecture is The Magic Moment, because generally we hit enter after putting in a URL or a search term, and we don't even think about the fact that something almost immediately shows up on our screen. But it really is a magic moment in time where all kinds of wonderful things are going on beneath your browser. And it reminds me of one of Arthur C. Clarke's favorite quotes: "Any sufficiently mature technology is indistinguishable from magic." And it certainly seems that way when we use our browsers. Well, this is what my browser start page looks like. Yours may be a little different, but almost all browsers have a box in which you can put either a URL or a search term. So let's start off by talking about what happens if you enter a web address. One of the nice features of the internet is that websites have names that are easy to remember. If you have a social group named Holland Thursday Night Scrabble Club, you can have a website with the address, quote, hollandthursdaynightscrabbleclub.org, unquote, just so long as nobody else has claimed that name. This is a great convenience for humans. However, for computers, not so much. The native language of computers is numbers, not words. So the first thing your browser does is call upon a domain name server. Now, a domain name server is a big database, a phone book sort of, that allows a computer to search for the words in a web address and translate that into numbers in a special format called IP, the Internet Protocol. There have been several updates to the IP. The most commonly used today is IP version 4. So we're going to look closely at the anatomy of a web address and get some terminology straight. Then we'll see how it translates a name into a number, just the way a phone book does. The entire World Wide Web has been broken into major categories called top-level domains. .com is for commercial companies. .edu is for educational institutions. .de is for German sites, and so on. Our HASP web pages are in the .edu top-level domain. Each top-level domain contains hundreds or maybe thousands of domains. In our case, Hope is the name of our domain under the .edu top level. A domain always has a computer that manages all the web pages within it. A large domain can have subdomains within it, like the athletics subdomain at Hope. Every subdomain also has a computer that handles its web pages. And a subdomain could have subdomains within it. There's really no limit. The beginning of a web address is almost always the same, http://. That says that the hypertext transfer protocol should be followed. And www specifies that what follows is a universal resource locator, or URL. This is going to be leading us to a file somewhere on the World Wide Web. A domain name server is the phone book of the internet. Actually, it's a hierarchy of phone books. One name server for each top-level domain. In the .edu name server, there's an entry for each registered domain. For Hope, the entry says 209.140.197. That means that Hope College uses 3 of the 4 numbers in its IP address to designate the address of the college network. That's all the name server knows. The 4th number is a host address that Hope assigns. Hope designates a particular computer in the Hope network to handle all of its web pages. Of course, your browser needs to find a particular web page, not just a computer. If you don't specify anything, the default page is always named index.html. Every host computer has a file named index.html. That's the home page for that host. Most of us usually want to go straight to the HASP page on Hope's host, so we add /hasp after the top-level domain. Again, that's convenient shorthand for humans. The host computer translates that not into a number, but into the path name of a file that holds the HASP homepage. In this case, it says, in order to find the HASP homepage, go to the Offices directory or folder, and inside that, go to the Hope Academy Senior Professionals directory. There, by default, it will look for a file named index.html. In a web address, if there's a slash after the top-level domain, everything following the slash describes the path to find a particular page, or maybe some shorthand for it. The extension HTML indicates that file contains commands in a language called Hypertext Markup Language, HTML. That language was invented 30 years ago by Tim Berners-Lee, a young researcher at CERN. It was intended for putting scholarly papers on the internet. As you know, academic papers always have to have lots of citations at the end. A paper created in the HTML language could allow the citations to also be links to the paper cited. This would be an enormous time saver for academics who wanted to look at the papers cited. Little did those early academics know that HTML would become the powerful tool that it is today for creating web pages. Every web page you look at today is defined in an HTML file. Now, that protocol has been updated several times, but Berners-Lee's original inspiration is still the basis for everything we browse. So hopefully, you now understand how your browser finds the web page you asked for and what kind of file encodes the page that it displays. Now, what does hypertext markup do? Well, it describes how a web page should look and allows those links. But to get to that HTML file, we have to find out how the computer on your desk communicated with the host computer at Hope College. Well, the browser hands off any request to the data communications tools on your computer. I'm not going to go into much detail here because it is really complicated. Think about the challenge. Any kind of computer running any operating system with any kind of internet connection is able to talk to some other kind of computer, operating system, etc., without knowing anything about the other computer. How would you solve that problem? The early designers of the internet solved it with a whole series of protocols. These protocols are like contracts. They say, if you send me this kind of message, I promise to provide these services. The whole set of them is called the TCP Ip Stack. Every time your browser sends or receives data, it calls the TCP Ip Stack on your computer. TCP IP stands for Transmission Control Protocol, Internet Protocol. We won't delve into them, but there are 4 layers in the stack: the application layer, the transport layer, the network layer, and then the network interface layer. Each layer does part of the data communications job and does it with absolute reliability. Every operating system and computer is free to create these layers any way they like, but the contracts between the layers are strictly enforced. The stack provides lots of services that, frankly, we never have to think about. But just in summary, here they are. The first thing that the stack does is it breaks up our messages into packets of data that are our standard size and format. Each packet has the address of the sender and the address of the receiver. The packets are numbered so that they can be reassembled in the right order at the receiving end. And the flow of packets onto the net is controlled so that the machines at the other end aren't overwhelmed. The layer asks the receiving computer to acknowledge receipt of packets. If an acknowledgement is not received within a set period of time, and that's pretty short, then the packet is resent. If you're doing something that requires security, like banking or purchasing something with a credit card, your browser will use the HTTPS protocol, the Hypertext Transfer Protocol Secure. The stack will handle the encryption and the decryption of all your secure transmissions. The stack will also change all the letters and symbols that we type into ones and zeros. That's called binary code. Incoming messages are decrypted if necessary, and then converted from binary into letters and symbols. That's what your computer does to get your data onto the internet. Once it leaves your house, the internet itself manages the communication. Each packet will travel through several internet nodes. Each node will read the address of the target computer and then consult its routing tables to see where it can forward the packet that will get it closer to its destination. Each node has a queue of packets waiting to be handled. If a node starts to develop a backlog, it will send out a message to the other nodes so that they can avoid it if possible. In order to give each packet the best service, every node tries to forward the packet along a path with minimal waiting times, at least at this instant. Now that means that sometimes the fastest path from sender to receiver will be somewhat circuitous. A packet may travel thousands of miles to go between 2 computers that are only a few hundred miles apart. In the early days of the internet, most of the network nodes were built by the Pentagon and by government research labs. They were located in windowless buildings on the outskirts of Washington, D.C. At one time, about 70% of all the data packets in the world would pass through a node within 50 miles of Washington on any typical day. The net tries to keep any nodes from being overwhelmed, and your computer will not try to send packets too rapidly to the destination. But malicious hackers can gain control over hundreds or sometimes thousands of PCs with their malware. And they can instruct all those PCs to send messages to one particular destination computer that will overwhelm that particular computer. This is called a denial of service hack, and there's nothing the internet can do to stop those attacks. Once the internet has successfully routed packets to the destination computer, it still has some work to do. It will acknowledge receipt of each packet, sending a tiny message back to the sending computer. Again, the path back to the sender could be circuitous. It will keep the packets in numerical order as they're received. If a number of missing, or if it's been too long a period, the receiving computer will ask the sender for a replacement packet. When all packets have been received, then the message will be put together, translated from binary into regular letters and symbols, and decrypted if necessary. If your browser requested a web page and that HTML file has now been received, then the browser must figure out how to display the page. The computer that served you the file doesn't know or care what kind of browser you're using, or how big your screen is, or even how you handle colors. Your browser knows all that. It will figure out the best way to display the page as instructed by the HTML file. Those computers and data connections did a lot of work, and it all happens flawlessly, billions of times every day. But the biggest miracle is how fast it all goes. If you're loading a page of mostly text with just a few images, it happens in approximately 1/10 of a second. Now you can verify that by loading google.com in your browser. That's a pretty sparse page, mostly with text. Of course, most web pages don't care about how fast you can load them. They only care about how many video ads and how much clickbait they can pile on. Video files are very large, so they take longer to load unless you have a super fast broadband. Now, let's stop at this point and say, do you have any questions so far about the first level of magic?
Nothing in the chat yet, Gary.
Okay, well, I'll have to say something to wake everybody up. Okay, so that's how the magic happens when you put in a web address, a URL. But what if you put in a search term? Well, then there's going to be some more magic. First, your browser will try to interpret the input as a universal resource locator or a web address. Now that's going to fail, so then it will treat it as a search request. All computers have a default browser, either the Internet Explorer on Windows or Chrome on Chrome or Safari. And each of those browsers has a default search provider. Now you can change browsers and you can change search providers, but the vast majority of people simply use the defaults. And the default is probably Google. Google handles 92% of all searches nationwide, worldwide. Now search is a huge moneymaker. Google earned over 180 billion last year just from search ads. Now, some of those ads are placed on the side of the screen and are easily recognized as advertising. Here's what I got recently when I used the search term electric bikes. The ads on the right side are pretty obvious, with pictures, prices, and links to web pages for particular e-bikes. Somewhat less obvious is the word ad at the top of each of the search results presented. These are all legitimate websites in response to my search, but maybe they would not have been the most relevant or the highest rated responses. Each of those companies behind the web pages paid Google for the privilege of being displayed first. The one that paid the most gets the fanciest display. Now, if you scroll down a bit on that results page, you'll find a convenient map of your area with big red flags showing the locations of 3 shops that sell electric bikes. Below it are street addresses, phone numbers, ratings, and hours. How convenient. Notice those smaller red dots? Those are also shops that sell electric bikes. And if you click on the View All button, you will see all the bike shops and their contact information. But 3 of them are featured on the first page. Guess who paid the most? By the way, how did Google know where you're located? Well, it keeps a cookie on your PC with lots of information about you. Unless you turned off its authority to know your location, it can tailor the ads precisely. Is that convenient? Absolutely. Is it scary? Well, maybe a little. Google's rapid, stunning success is quite a story. It's not quite a rags to riches story because Stanford students generally are not poor, but the riches are quite real. In 1998, two very bright Stanford grad students presented a paper at a computer conference. Larry Page grew up in the shadow of Michigan State. Yay, Spartans. Unfortunately, he graduated from the University of Michigan. Sergey came to the US at age 6. He graduated from the University of Maryland. They both went to Stanford for grad school. Their paper introduced an algorithm for ranking all the web pages that matched a search term. They called it PageRank, a deliberate play on Larry's last name. Now, their prototype search engine that demonstrated their algorithm was called Google. This was also a pun. A Google is a large number, a 1 followed by 100 zeros. They joked that this was how much information they could find. When they became a large, rich corporation, they built a headquarters complex in Silicon Valley. They called it the Googleplex. That's also a pun. A Googleplex is a 1 followed by a Google zeros. Their search engine was so successful and so dominated the search industry that Google went from an obscure prototype to a verb in 4 years. The American Dialect Society named Google, a transitive verb, the most useful word of 2002. And by 2008, even the rather stuffy Oxford Dictionary included it. Google's success was not because they were the first search engine, but they did the best job of combining all the earlier ideas with their own clever method to produce a truly useful search engine. Archie was a tool that collected all the directory listings of sites that allowed free downloads of files. Why did Archie look for free downloads instead of web pages? Because there weren't any. HTML was just being invented. Now, a quirky sense of humor is required of computer scientists. 2 improvements to Archie were named Veronica and Jughead. And if you don't recognize those names from the comic strip, you're too young to be in this lecture. A really important engine was initially quite successful, Yahoo. 2 early pioneers of the internet, Jerry Yang and David Filo, liked to roam the web looking for interesting websites. When they found an interesting one, they stored the web address in a special file. This may be one of the earliest examples of bookmarking. When the file got so big that it was hard to find anything, they organized it by topic, manually, and they called it their directory of the internet. They shared it with a few friends who loved it, so they launched a company to commercialize it. They called it Yahoo, an acronym for Yet Another Hierarchically Organized Oracle. They hired people to help edit and expand their directory, and in '95, they created a search engine whose only job was to search this large directory. For a while, Yahoo was the most popular search engine on the web. In 1997, Ask Jeeves was launched. Its claim to fame was that you could type in a plain English sentence asking a question, and the engine would convert that into a standard search query and then search the web for an answer. Now, today's smartphones do this with spoken sentences, and we don't think much of it. But in 1997, natural language understanding was considered quite advanced, almost miraculous. So, how do today's engines work? Well, they use a variety of sophisticated tools. Here are some interesting examples. A web crawler is a computer program that starts by loading one web page, just like a browser does. But instead of reading the HTML file to see how the page should look, instead it searches the HTML code for links to other websites. A copy of this HTML file is saved in a massive database and indexed according to its subject matter. It makes a list of all the links found in the first file and then loads each of these pages in turn and does the same things. Soon, the list of links to visit is very large, And the program has followed a series of links to all kinds of sites all over the web. Eventually, a program like this crawls over much of the web. It has two end products: the database of saved pages and the index to the contents of those pages. Now, you've probably heard the term that the internet never forgets. Well, the database of saved pages is why. Even if you delete a web page from your local server, the odds are that Google or one of its competitors has saved a copy, and you can't delete Google's copy. These databases of saved pages are huge, and the index of their contents is even bigger. Google's search index covers hundreds of billions of web pages. Its size is over 10 million terabytes. That's enormous. The search index is in a format called an inverted file. If there were a file named sheep and it contained the sentence, "Mary had a little lamb," the index would have 4 entries. An entry for the word had would say that the word occurred in the file sheep in location 2. The entry for lamb would point to location 5 in that file, and so on. In essence, Google's search index is like the index at the back of a book, but with an entry for every word in the book except common words like a, an, of, and so on. Why do they use inverted files? Because it allows them to quickly find web pages that contain certain collections of words. If you input the search term Hope Academy of Senior Professionals, Google would first find the search index entries for Hope, Academy, Senior, and Professionals. Now, each of those words points to thousands or maybe millions of pages. But using a very fast database function, they could then produce a list of all the pages that are pointed to by all 4 entries. Then they look at each page on this smaller list to see if the 4 words are located near each other. Or they could even insist that all 4 words must be within a certain span of, say, 5 or 6 words. That will generate a really small list of web pages. The search index has reduced the size of the problem tremendously, but we still have to figure out which page is the best, which one is second best, and so on. And that's where Larry Page and Sergey Brin's idea pays off. Their PageRank algorithm is amazingly effective. Here's a diagram that may help you to visualize how PageRank works. We're trying to find the most important page. A page is important if a lot of other important pages point to it. Such a page is called an authority because it's cited by many others. A page can also be important if it points to lots of other important pages. That would be called a hub page. Now, in this diagram, B is important because lots of other pages point to it. And C is important because B points to it. E is somewhat important because it points to very important B, and also because it's pointed to by lots of pages. Now, you've probably detected some circular logic here. The importance of one page is determined by the importance of other pages, and their importance is determined by still other pages, and so on. Now, fortunately, computer science has what we call convergence algorithms for problems just like this. We start by assigning the same importance to each page. Then we apply the algorithm to identify hubs and authorities, increasing their importance. Then we run the algorithm again, only we use these new values for importance. The second run gives us slightly different results, but then we use those results for a third run, and so on. Eventually, all the runs give us the same answer. They have converged to a solution. If our diagram represents the convergence solution, then B will be ranked first in the search results, followed by C, E, D, F, and so on. Because their page ranking worked better than anybody else's, Google became the most successful search company. They were able to hire lots of bright young folks who made other improvements to the search experience, like word stemming. Certain words can be reduced to a stem so that other similar terms are also found in the results. For example, if you input a search term of translator, it would reduce that to a stem of translate. And therefore, the results you see could also include results for pages that have translation on them. They also introduced methods for handling acronyms. Searching for abbreviations can also return results about the name in its full length. For example, if you search for NATO, the results will include pages that refer to the North Atlantic Treaty Organization. Google handles misspellings. They'll often suggest correct spellings for misspelled words. Google also maintains large database of synonyms. In most cases, where a word is incorrectly used in a phrase or a sentence, Google will show the search results based on the correct synonym. They also do language translations. The search engine can, in some instances, suggest results for specific words in a different language. And finally, they've learned how to ignore words. In some search queries containing extraneous or insignificant words, Google search will simply drop those words from the query. Now, these are all things that Google does for you automatically. Google also allows you to customize your search in a number of powerful ways. You can experiment with these at home. If you put in the word or, that means search for a web page containing one of two similar queries. You could then put marathon or race. If you put in a minus sign, that means exclude a word or a phrase, such as apple minus tree will search for pages where the word tree is not found. If you use quotation marks, that will force the inclusion of an exact phrase, such as tallest building. If you put in an asterisk, that's a placeholder symbol. It allows any word to be substituted for the asterisk in the context of the query. If you put in largest asterisk in the world, that would give you largest building, largest ocean, largest mountain, etc. If you put in ellipsis, that allows you to search within a range of numbers. Like you could search for a camera, $50, $100. You can also put in a keyword of site with a colon after it. You can then search within a specific website. For instance, you can do a search and say site youtube.com. It will only give you results coming from YouTube. You can use the word define to let Google know that you are wanting to find the definition of a word. If you say stocks, Google will look up a stock price. If you say related, Google will find web pages related to a specific URL address, such as related to Wikipedia. If you put in the word cache, Google will highlight the search words within the cached pages. So if you said cache, www.google.com, and then put in search terms, all your results will end up with the cached word highlighted. If you use an @ sign, this will tell Google to search for a specific word on social media networks. So, when you do a web search from your browser, you get double magic. When your browser figures out that your input is not a URL, then it sends your search request over the net the same way it would send a web page request. Just remember all the amazing processes that entails. Then Google does its own brand of magic to perform the search. When it has finished, it creates a web page in HTML containing all the results and a few ads. That results page is then sent back over the internet just as though it were a web page that you had requested. Your PC is the destination computer, and it sends receipts back to Google as each packet is received, and so on. The final result is that all of that magic happens in less than 1 second. I've been in this field all my life, and I still find that astonishing. By the way, if you've ever wondered why an inexpensive PC needs to perform millions of operations per second, this is a big part of the reason. No matter how complex the search, the double magic beneath your browser happens in less than 1 second. Let's stop again for questions, comments.
Gary, do you have any statistics on the computers that Google uses to store these and run their search engines, and the electricity required to use that?
Well, that's a really good question, Bruce. I don't have statistics, but I can tell you that Google runs so many CPUs, so many computer central processing units, that they found that it really didn't make any sense to buy them from manufacturers, because all these CPUs were going to be forming one simple process many, many times a second. So they designed and built their own, I guess you call them blades. It's a motherboard with their own CPU design on it. And they have rooms filled with rack after rack after rack of these blades, all of them performing the same function and performing it exceedingly fast. They also, they buy, I believe they buy their disks, but they again have special communication protocols in their big windowless warehouses so that the storage and retrieval can be super fast. The amount of electricity required to operate one of these data warehouses is pretty enormous. When Google made the commitment a couple of years ago that they were going to power all of their data centers with renewable energy, that was a big deal because they consume a lot. Most of the electricity in those data warehouses is not used for the computers themselves. It's used for air conditioning to deal with the heat coming from those computers, because there's just so much going on at the atomic level that the heat produced would be more than enough to fry everything in the building if the air conditioning ever went off. They have more than one data warehouse. I don't know how many, but they're scattered all over the world. And of course, they then route their queries and their responses among those warehouses on an instantaneous basis to balance the loads around the world. Good question, Bruce. Any other?
There's a question in the chat. Well, two of them are the same. Maybe you could go back to the slide, Gary, that had the list of tips, search tips. People are asking for that. Great, awesome. And then from Myron, do all these supercomputer storage centers, like the newer one on the southeast side of Grand Rapids, store the internet in a redundancy manner?
That's true. I think they're referring to that pyramid-shaped building just off M6.
Okay.
Yeah.
And then Anne is saying, this may be a naive question, but with such amazing speed, how do hackers intersect with Google or other search engines?
Can you repeat that question?
With such amazing speed, how do hackers intersect with Google or other search engines?
Well, hackers don't normally, by the way, I'll put the other page up too. Hackers don't normally try to intercept Google searches. But what hackers will do, and this is a common one that you're probably all aware of. If you go into a Starbucks and decide to use their free open internet, you're on an unsecure network. A hacker with special programs sitting in that Starbucks can try to screen or to look briefly at each of the packets that's flowing out of that Starbucks. Most of the packets it will completely ignore. But if it finds a packet that's using the HTTPS or secure, it will then attempt various methods for trying to decrypt or figure out what's in that packet, because it probably has to do with credit card numbers bank account numbers, and so on. An actual Google search itself on the way, from your computer to Google probably is not going to be the target of a hacker. It's generally hackers are after things with financial implications. I hope that's an okay answer.
Great, thanks. That's all I have right now.
Okay, well, now that I've told you how wonderful it is to search for information in your browser, now I have to turn your attention to some of the problems and cautions. We've been hearing a lot lately about implicit bias. Now let me tell you how I'm using that term today. I mean the unintentional and often unaware introduction of improper, harmful bias into your browser results. I'm not referring to bias that we intentionally incorporate in our web browsing. If you're a fan of Governor Gretchen Whitmer, you'll probably favor websites that treat her kindly, or the opposite may be true. That is bias that you are aware of and that you've explicitly chosen. Well, that's fine. Neither am I referring to proper, trivial, or harmless bias. What's proper bias? Well, if you read web pages from the local area, you'll see a lot of pages that depict West Michigan as a desirable, fun place to live. Now that's a little biased, but it's perfectly fine for, say, the Holland Sentinel to have such a bias. You'd also call this harmless or trivial. Another example of harmless bias might be the tendency of certain collections of websites to favor Apple computers and devices. Other sites might favor Android and Windows. Some sites exaggerate the virtues of Chevys or Toyotas or Hondas or Teslas. Now that's biased, but it's pretty harmless, unless you're the Ford dealer. I'm talking about biases that are generally agreed to be improper and harmful, those that are racist or sexist or defamatory of certain religions and so on. You would not consciously allow such biases on your browser, and yet they exist. How did they get there? And why do we need to be aware of them? Some of the bias in your browser is produced unintentionally by you. You may think of your PC as a window on the world, but many companies that live on the web think of your PC as a cookie jar. Most of the websites that you visit place cookies on your machine. This is so common that the operating system of your computer provides a special storage location for cookies to keep them out of your way and also keep them out of sight. A cookie is a small file that records some useful things, like what document you used last, or which user is logged on a family computer, or preferences that you like, or items in your shopping cart, or maybe your physical location. A cookie also may record what you've looked at recently, what you've bought or shopped for, and indicators of your income, your address, home ownership, and employment status. Those cookies help to determine where your browser takes you and what it tries to show you. Many sites will inform you that they use cookies, and they'll even offer to show you their privacy policies. But preventing cookies is a hassle, and that's on purpose. Every time you do a search, Google records it. After a few hundred searches, your history can help Google figure out that when you say ball, you're referring to sports, not formal dances. It also lets Google remember what you may be interested in. Okay, so you do a search on Google, and Google sells ad space to companies based on your search term. So all the ads you see on Google are related to your immediate search. That makes sense. But how does an ad for what you shopped for on Google appear next to a newspaper article that you're reading, even if you didn't find that article with a search? This is called user tracking. In effect, it is all of the companies who are trying to sell you stuff cooperating so they can gang up on you. When Menards.com puts a cookie on your PC, that cookie contains data that will help Menards tailor your experience and remember things about you. But if a website contains ads from a third party, those third-party advertisers are also allowed to put a cookie on your PC. In 2014, a study found that the average website placed 10 cookies on your machine for every visit. The biggest was over 800 cookies placed in one visit. And some cookies can be shared by multiple sites, maybe 100 advertisers. These third-party cookies allow many companies to track your browsing history and draw inferences about you, what you read, what you buy, or where you shop. Some people find this disturbing. Others accept it as a way to assure that the clothing ads they see are for brands and styles they like. A slightly more insidious bias is confirmation bias. Now, you've heard about this term probably in discussions of how people read newspapers or choose their TV news programs. That is your choice, after all. But there's another confirmation bias that you don't choose and you're unaware of. Because of user tracking, many companies and websites have created a profile of you. You'd be surprised how detailed those can be. They include not only your buying habits, but your religious beliefs, your political views, and even your guilty pleasures. Facebook is the obvious example of hidden bias. If you spend a lot of time posting and viewing, Facebook has a very detailed dossier on you. And if you have been profiled as a political conservative, most of the items in your newsfeed will be favorable to that view. Postings by people who Facebook thinks share your views will be more prominent. Have you ever heard someone say, well, everything I'm seeing says that COVID-19 is a hoax? Well, those people are sincere. If Facebook or other news aggregators have figured out that that person is a virus denier, then they are deliberately shown things that confirm their pre-existing view. There's also a mirror image of confirmation bias called rage triggers. Facebook's #1 goal is to keep users engaged as long as possible. Feeding you news that confirms your biases is one way they can do it. But another way is to occasionally show you something that Facebook thinks will make you mad. If you make a contradictory posting or otherwise express your rage through Facebook, then you're strongly engaged and Facebook is happy. Perhaps the most insidious bias is invisible racist bias. Of course, if those third-party cookies have built a profile of you that labels you as a racist, then that's going to shape the news and views that you see online. But invisible bias is not based on you. It's built into the internet. You can't block it with the privacy settings or preferences in your browser. You can't filter it out. There's no way to identify it automatically. You simply can't control it. Where does the invisible bias come from? Well, partly it springs out of the structure of the World Wide Web and the algorithms that traverse it. Remember Google's PageRank algorithm? That says a web page is considered important if lots of other important pages point to it. Well, as of 2016, 61% of the US population is white, non-Hispanic. 16% is white Hispanic, and Black America is 13.5%. So if we assume that internet usage is evenly distributed among all the ethnic groups, which it is not, then the pages that are often visited by white Americans will be considered more important than pages frequently visited by other ethnic groups. And white, non-Hispanic Americans have greater access to the internet than most other ethnic groups, so their influence is even greater. Thus, PageRank, this very objective and successful estimate of importance, automatically gives white views more weight than other views. No one planned it that way. It just reflects how the net is used and by whom. And there's no easy way to fix that problem. This is a reflection of a broader problem because much of the behavior on the web is data-driven. One of the ways a digital enterprise can attract customers is by making sure that each customer experience is tailored to that customer. Netflix and Amazon were the pioneers of this approach, but now it is widespread. Any website that sells merchandise nowadays will make recommendations about what else you might like to buy. You rent a movie on iTunes or Amazon Prime or Netflix, and you'll be shown a list of other similar movies. If you buy bicycle shorts, you'll be shown biking jerseys and bike shoes and jackets and so on. Obviously, those companies have not hired thousands of people to analyze each customer and each purchase. They use algorithms to automatically generate recommendations. Those algorithms are often based on large volumes of data. Some are based on an artificial intelligence technique called machine learning. Now, machine learning involves reviewing millions of records to find the patterns in the data. It will produce a black box program that can use those patterns to categorize or label new records. For example, Google let a machine learning system review millions of pictures of animals. Some of them were labeled cat and others were not. The result was an AI program that could identify cats in any photograph, including photos that it had never seen before. That's pretty cool, right? But if the data that trained an AI system is biased, the resulting black box will contain that bias. And because no one can see what's inside the black box, the bias is invisible and undetectable. Now, maybe you're thinking those lazy computer geeks should get busy and read all the boxes before they use them, but they can't. The black box contains millions of numbers that represent the weights on thousands or millions of nodes in a giant network. There is currently no way to interpret how the black box works. It just works. And most of the time, it works pretty well. Here's an example of the problem from the criminal justice system. Many sociologists had pointed out a problem in the sentencing and parole statistics of our legal system. White people receive lighter sentences and earlier parole than people of color. Because the majority of judges and parole boards were white, they thought the system was biased, albeit unintentionally. One proposed solution was to create an AI system to recommend sentences and paroles. An impartial computer could reduce the unintentional bias of the judges. This seemed like a no-brainer. A team of AI researchers built a system to predict the risk that a particular defendant would end up in prison for a subsequent crime. If a person was likely to commit more crime, they could be locked up for a longer period or could be denied parole, thus protecting society for a longer period. A judge or parole board could consider other factors, but this AI system, supposedly completely objective, would give them some objective data to begin. But there was a problem with the approach. The AI system was trained on a lot of data about repeat offenders, including the severity of subsequent crimes. But the data reflected the racial biases in prior sentencing and parole decisions. And the AI system learned to make recommendations just like the ones it was trained on. And you might think the fault here is that the system builders used the wrong data, but they used the only data. Remember that the machine learning techniques involve massive amounts of training data. AI researchers have to use the data that's available. Here's another example, this one from real estate. Before the civil rights legislation of the 60s, banks practiced redlining. Under guidelines issued by the FHA, they would draw maps of the community showing where the risk of mortgage default was low, medium, or high. Naturally, a bank would not want to offer a mortgage on a home in the riskiest area, marked by red lines on the map. Often, the redlined areas were Black communities. Redlining is now illegal, and the practice in the banking industry has been mostly stamped out. When prospective buyers walk into a real estate office, it's the job of the agent to generate a list of properties to show based on the age, financial strength, family size, and so on of the buyers. But if the agent has a secret belief that introducing a family of color into an all-white neighborhood would lower property values, and therefore lower real estate commissions, that agent will not show certain properties to a Black couple that they would show to an otherwise identical white couple. This form of discrimination is much harder to police, but researchers posing as buyers have proven that Black couples with identical characteristics to white couples are shown different homes. Well, this problem can be solved through impersonal, colorblind internet tools, right? Wrong. It has still been shown that people of color are shown different real estate ads online, even though their race has not been identified. How does that happen? Well, recall that third-party cookies and profiling databases can accumulate a lot of information about a person. Your race can be inferred pretty accurately if there's a normal amount of data in your profile. The same information used to infer your race can also be used to target an advertisement. Without ever explicitly mentioning race, a form of online discrimination in housing can be practiced. Now, sometimes online discrimination is deliberate, but it's also possible to train algorithms on data that reflects past discriminatory practices. Those algorithms will perform just as they've been trained. Another bias that everyone finds disturbing is bias injected into our browsers by hackers. I said earlier that no one can see inside the black boxes that machine learning produces, and that's true. But it is possible to study how a black box behaves. It's not easy, but if you figure out how an AI system responds to certain kinds of data, then you can rig the data to make it behave in certain ways. Remember the Cambridge Analytica scandal during the 2016 presidential campaign? The Trump campaign hired a British AI firm to use social media to promote the Republican candidate. Cambridge Analytica figured out how Facebook's AI programs decided which news or postings to show to any one user. Then they surreptitiously downloaded the personal profiles of tens of millions of US Facebook accounts. That allowed them to figure out how to tailor postings and misinformation disguised as news so that it would be shown to the voters that they wanted to target. The Facebook news feeds for targeted voters became highly biased, unbeknownst to them. Their accounts had been hacked in a sense, but the method was simply to steal data and then create false accounts with misinformation. The hackers then let Facebook's AI algorithms do the dirty work. Now, there have been some successes in eliminating implicit bias in AI systems. A radiologist's job is to look at images like this one. Almost all of them are digital these days, and the radiologist gets paid to interpret them. Because the subject matter was digital, this was a medical specialty that received early attention from AI researchers. The standard machine learning approach was used. They made a database of thousands of images, then they got expert radiologists to label each of them with the proper interpretation, and then they trained an AI system. Sure enough, an AI system built from a big enough database could interpret these images more accurately than any single expert. This was a great success for AI. But there was a problem. The AI systems didn't perform as well on images of Black people, just as the human radiologists didn't. So a new approach was tried. An AI system was trained on X-rays of knees where arthritis was suspected. But the labeling wasn't done by radiologists. It was done by the patients themselves. The resulting system did a better job of identifying images associated with knee pain, and It worked better for both white patients and patients of color. In this case, the problem of bias implicit in the data was solved by changing the source of the labels. Now, it's not clear how this approach could be applied in other areas. In criminal justice, for instance, the labels on the data come from court decisions. There's no obvious alternative. But we can hope that this example will inspire other researchers. Related to this, I can offer one other hopeful note. Most researchers are now aware of the danger of invisible bias in data. But all research, especially in universities, is done on a limited budget or on a grant with a fixed cost. And creating new databases from scratch is time-consuming and very expensive. The bias is usually in the labels on the data, but changing labels usually requires many hours of human labor by experts. That's just too expensive. Recently, several teams have worked on methods for training an AI system with far less data, without reducing the accuracy of the system. If these techniques work as expected, then the cost of creating a new data set from scratch will be greatly reduced. Now, in some cases, this may cut the cost enough to make it practical to create new bias-free data sets. That will certainly help. So, what can we do? I hope I've shown you that eliminating systemic bias is not simple. Much of the stunning recent success of machine learning is because more and more data is available through the internet or in digital form. That makes huge training sets possible. But all that data comes from the world as it is, not the world as we'd like it to be. The first step, of course, is knowing that it exists. As our society becomes more and more alert to implicit racism, we'll be able to see it more easily. The hard question is what to do about it. When the political right became convinced that social media platforms were discriminating against conservative viewpoints, they confronted the platforms, the owners of the systems containing the alleged bias. It's really not clear whether the allegations were true, but it is crystal clear that when system owners are dragged before congressional committees and pummeled in the press and the subject of thousands of complaints from their customers, they pay attention. Perhaps the owners of online systems can become equally motivated to root out implicit racism or sexism or bigotry. At least we can hope. Again, questions, comments?
There's a couple in the chat. The first one is referring to your Starbucks example, how much protection does a VPN provide?
A good solid VPN provides complete protection.
Okay.
That's not to say that the NSA couldn't get around it, but your everyday hacker and even some pretty sophisticated hackers would be completely unable to break a VPN.
Okay. And then from Barbara, she uses Mozilla. Usually its claim to fame is that it doesn't save history. How does that work?
Well, Mozilla is the maker of a browser. Now, I talked about a kind of history in this lecture in which web crawlers create a history of pages visited, and also where cookies record the history of your searches. Mozilla is referring to the second kind of history. Mozilla does not keep a history of your searches. So therefore, that information is not available to other people that are trying to find out what you're interested in buying.
Great. And then from Suzanne, if advertising comes to something and you are not interested in or did not put out a feed for, and you let them know on that site, then what happens? Not sure what the question is.
Well, that depends on who the advertiser is. In some cases, ads are simply clickbait. Clickbait is something that looks like something you might be interested in, but in fact It's just trying to lure you into clicking on a link that will then take you someplace where they can attempt to either steal your data or lure you into giving them information. For that kind of, I would say, illegitimate advertiser, one of the things they're trying to do is to figure out which kinds of people will actually respond to an ad. So if you even respond by saying, I don't want to see these kinds of ads, if you make that response directly to the advertiser, that may simply put you on a list of people that responded. It could make things worse. On the other hand, if you're looking at an ad that was placed by Google, and quite often there will be a little bar at the top of the ad that allows you to skip this ad or delete that ad. And that little bar will usually have the Google symbol on it. That means that the ad was sold to the advertiser by Google and then placed on this particular web page because of a contract between Google and the website owner. If you respond to an ad by clicking on Google's little bar and indicating, I don't want to see this kind of ad, the advertiser doesn't get any information about you. Google just knows that you don't want to see ads of that type. It's probably quite safe to delete an ad or say, I want to skip ads like this if it's from Google. But if you're clicking on clickbait, almost always that's a bad idea.
Okay. That's all I have in the chat. So if anyone else wants to unmute themselves and ask questions or make any comments, please feel free to do so.
Yeah, this is Tom Coney. I have a question about the cookies that are put on our computers. It is possible, I think, to go into the system and delete cookies.
Absolutely.
Does this truly delete all of the cookies or just some of them, or is it an okay thing to do?
Well, people in the privacy posse would say deleting every cookie is always a good idea because they just think cookies are a bad idea. Some cookies are actually helpful. For instance, when I use the Hungry Howie app to order a pizza, it remembers what my last order was. It used a cookie to do that. If I were to go in and clean out my cookies, I would try to save the cookies for Hungry Howie and save the cookies for Panera, but get rid of all the others. That's a lot of work. Most people aren't willing to do that much work. And of course, cookies are being placed constantly every day. Every time you visit a web page, you're either getting or updating at least one cookie, and usually many more. So it's kind of an endless battle. But yes, people who are sophisticated computer users can go into their hidden files on the machine and they can delete cookies.
Well, aside from this inconvenience of ordering a pizza or something where they're useful, would it be, I mean, if you can get past that convenience, would it be reasonable to empty the cookie tray each day?
Sure. Now, there will be cookies played, for instance, if you're buying something online, if you buy one item, you'll usually see a symbol of the shopping cart, and it'll have a 1 on it. And then if you buy something else, the shopping cart will have a 2 on it. That shopping cart is driven by a cookie. And that cookie is being produced in real time. After you've finished your shopping expedition, deleting that cookie doesn't hurt a thing. But if you prevented that cookie from being placed, then the shopping cart wouldn't work correctly.
Okay, so the information about your purchase, like say you went to Newegg and bought a hard drive, the purchase information is not being stored at Newegg, it's being stored on your computer in a cookie from Newegg.
Some of the information, yes.
Okay. All right. Thank you.
Question, Gary, is it common practice for organizations like the whatever group administers the sentencing recommendations to age weight their data so that, for example, sentencing records from Alabama in the 1950s would receive less weight than current practice?
I don't know. Sorry, Bruce. To the extent that academics are doing the studies, I would think that they would work very hard to try to control for factors that they think might introduce bias. But I do not know the answer.
I wonder if any of them have worked backwards, like having the data about who might get back into jail, but then finding 2 years from now they were wrong.
In one sense, any machine learning system does that if it tracks its outcomes.
Okay.
Of course, that doesn't help you when you're trying to make the sentencing decision today.
No.
But yeah, systems can get better over time when they measure their successes. In fact, there is one particular brand of machine learning called reinforcement learning, where that's the only mechanism, where the system constantly makes initially stupid predictions and finds out which ones were correct. And it keeps learning from its mistakes until it gets to the point where it can make good predictions. And a system like that, of course, the longer it runs, so long as it gets feedback on whether its predictions were correct, the better it gets.
Gary, this is Myron Burnett. Are there any organizations that you're aware of, whether it be through a church or whatever, that are investing in fighting a lot of this biasing that you just woke us up on? I did not realize this. Thank you for bringing it to our attention. But how are we going to fight this? And like I said, are there any organizations we should be supporting?
Well, generally, let me stop the screen share. Generally, organizations that are devoted to civil rights are very much aware of these biases. And some of them are more technologically savvy than others, but I don't think it's the case that there are special organizations that are focused only on technological bias. I think it's more of the case that organizations that are trying to fight bias are becoming increasingly aware that they have to include technology issues in their agenda.
How do you get rid of cookies?
That depends on your operating system. And I'll give you an easy out answer. Go into your browser and put in, how do I eliminate cookies? You will find that there are dozens of web pages that would like to tell you how to do it. Pick one for your operating system and it'll tell you how.
Okay, thanks.
Isn't that how we learn how to do anything these days?
Yeah.
I've had the experience a few times of just thinking about buying a particular thing, not clicking on anything, and I start getting ads. And is that just spooky or a coincidence or what?
Well, it might be coincidence, but remember, the profile on you for many of these vendors is really rich. So, if the profile on me undoubtedly knows that I like bicycles and I do a lot of bicycling. So the fact that ads for bike equipment show up next to my newspaper, not surprising at all.
Okay.
What mystifies me is I keep getting ads for women's clothes and I can't figure that one out. honest, I'm not a cross-dresser.
Isn't
funny
it true that
because,
some of the smart devices are listening in on us, at least from what I've read from Kim Commando's articles in the Sunday paper?
I'm not quite understanding. Are you asking what things like Alexa are
Yes.
getting information?
Yes, and I've heard that even some of our smart TVs could be recording and adding to our profiles, because it's been brought up, and that's the perfect example that was just brought up about, here you have not typed in anything in your computer, and you go and turn on your computer, and voila, here's something about e-bikes. And I never even typed in anything about e-bikes, but maybe my wife and I were discussing it earlier, and either Alexa or our smart TV may have picked it up. I'm just asking that. What's your thoughts on that?
Well, I have two thoughts on that. The official response to that question from all of the makers of these voice command systems is, we would never do that. But they've been caught with their hand in the cookie jar before. I think it is quite possible. Now, there is one legitimate reason why Alexa and others do, or at least used to, listen in on general conversation. And that is that Alexa's claim to fame is that she can understand human voices and understand human sentences. Well, she needs lots of data. And listening in on people talking is a great way to gather data about how people talk. So that's a legitimate reason why she was listening in. But these other illegitimate reasons may in fact be happening, but they won't admit it.
I've done a little bit of experimentation with a protocol analyzer and an Alexa device, and they say that it doesn't communicate until you say the keyword.
Mhm.
Like in the case of a Google device, hey Google, or Alexa, you say Alexa. The tests that I've done prove that out. I did, it's one sample in time, but the conversations that are going on between the device and their data center is pretty slight until the word is spoken.
That's encouraging.
Excellent. Thanks, Dave.
That's another classic thing in these deals and Gary, you've done another excellent job, but that saying that if the product is free, you're the product, I think is the phrase that one should think of.
Well,
Hey, Dave.
Excuse me, go ahead.
Well, I was just going to follow up on Dave's comment because I'm wondering too, what about free security systems? And do you have recommendations as to which of the available protection services are worthwhile and which are not to be used? I have an AVG free service. I've used my computer very limitedly. I seem to be adequately covered, but what do you think?
I
Are the
am.
free services?
I'm not an expert on security services at all. I would defer to Tom Coney, who I know has spent a great deal of time looking into that. I use all Apple devices, so I pretty much can ignore it.
Thank you.
Tom, did you want to weigh in with any of your information about malware detection and security systems?
Yeah, the idea of free applications like that, in the case of VPNs, the recommendation is not to use a free one. That it is so important that the person who is reading everything you transmit, in order to encrypt it, it's such a temptation. So a free VPN probably is not a wise move. If you consider that then to something like a malware antivirus software package, the difference between a free one may have some problems with it in that regard, but more so they have fewer features. So it's my opinion for myself that I want to pay for a antivirus software. Which one you use, there's several very good ones out there. It shifts around from year to year as to who's doing the best, but if you have a good one, it does the job, and they're not that expensive, maybe $50 a year or something.
Yeah, the principle from just buying things in general is you should always ask yourself, how does this person make a living? Or how does that company make a profit? If someone's offering you something for free, you have to wonder, they're not doing it because they love you. So where are they getting money? One of the reasons that I'm an Apple fan is because Apple's very upfront about the fact they charge more for their computers. But once they've charged for that, they've basically paid for all the other stuff that they can offer for free.
One of the reasons for offering free antivirus software is that it's a way of getting you interested in their product, and hopefully you'll shift to a paying version. There's another one which is interesting to me, and that is I have Kaspersky, and they collect information, security information, routinely on the people who subscribe to them, and use that for watching out for malware that is new to the world and reacting instantly then to that. So that the free software person, while they're using their software to protect their machine, they're also providing data to Kaspersky regarding what's going on out in the networks. So there is a couple of reasons why you might be able to use a free software, or why they might offer it. I don't know these AVG and the others that are typically free. Sometimes they perform as well as, but usually slightly less than the paid companies.
Oops.
I see we're getting pretty close to 11. Should we make a last call?
Anybody else? Very interesting and very scary all at the same time.
Thank you, Gary, so much for a wonderful presentation. Great detail, great interest, great relevance in tying a whole bunch of things together. Well done.
Thanks so much, Gary. Thanks everyone for being here. Hope you have a great day.